Welcome. This is a nice review using for periodic table exam, using a previous exam. Let's just jump into it. Number one, the elements on the periodic table are arranged in order of increasing atomic number. That's just a fact. Number two, which list of elements contains a metal, metalloid, non-metal, and noble gas? We'll take a look. K is a metal. Metalloid, well, that's a metal, so it can't be a C. Metal, we have beryllium is a metal. A metalloid is silica. Chlorine is a non-metal, and krypton is our noble gas. Which list consists of elements that have the most similar chemical properties? Remember, same group, same number of valence electrons, same number of similar properties. These are all in group 2, with magnesium, above calcium, and a bit farther down we have barium. 4, which element is electrically conductive and exists as a liquid at STP? Well, if you're electrically conductive, that means you are a metal. We have to narrow down. We have 2 metals here. We have mercury and iron. But as we know, the only liquid metal at standard temperature is mercury. Number 5, which property can be identified as the ability of a substance to be hammered into sheets? Well, remember, a hammer is the same thing as a mallet. If you are able to hammer it with a mallet, it is malleable. Which phrase describes the molecular structure of 2 forms of carbon, diamond and graphite? Well, these are allotropes. Remember, even though they contain the exact same atoms, they're going to have totally different molecular structures and therefore different properties. Number 7, what are 2 properties of most nonmetals? Well, it's a fact. We have high ionization energy and poor electrical conductivity. If you forget that nonmetals have a high ionization energy, please go to table S. Look up a metal like lithium. Look up a nonmetal like fluorine. You're going to see this has a very, very high ionization energy, and this is much, much lower. Number 8, the element in group 14, period 3 on the periodic table is classified as, well, we simply have to match up what is in group 14 and where period 3 intersects with that. And as we see, that is arsenic. Yes? I'm sorry, germanium. Sorry about that. That's going to be a metalloid. So first I see that it's germanium, and we know germanium is a metalloid. Number 9, which element is a liquid at STP? Well, there are 2 liquids on your reference table. There is bromine and mercury. Obviously, mercury is not listed here. Number 10, which Lewis dot diagram represents a nitrogen atom in the ground state? Well, remember, if I'm dealing with an atom, I go to my reference table, I look up the configuration of the atom, which is 2, 5. There are 5 valence electrons, so I draw N, and I do a total of 5 dots around it. If I was asking for a nitrogen ion, nitrogen being a nonmetal, gets 8 dots, square brackets, and its charge, which according to your reference table is -3. Be careful, this is the atom, which is what they're asking for, while this would be the ion. I needed to go back to number 8. The answer is still metalloid, but I was a little sloppy. 14 and period 3 do not intersect at germanium, but at silicon. Number 11. Which Lewis dot diagram is correct for a sulfur -2 ion? Here's the ion. Remember, all nonmetals are identical in that they get a total of 8 valence electrons. They get square brackets, and they get their charge. So you have to know that there's always 8. 8 is great if you're a nonmetal ion in your dot diagram. Elements that have atoms with stable valence electron configurations in the ground state, well, the only group that has stable configurations, meaning a full valence shell, are in group 18, otherwise known as the noble gases. Number 13, when an atom of lithium loses an electron, the atom becomes a... Let's see what that looks like. Lithium is 2, 1 in the ground state as an atom. When it loses an electron, it loses that whole outer shell to become just 2. Now, when you lose a whole shell, well, your size must decrease. not increase. The atom becomes a positive ion with a smaller ion, and if you look it up, lithium is always a positive 1 as an ion. So the answer here has to be C. 14, which particle has the same electron configuration as a potassium ion? Let's look at that. This is the configuration of a potassium atom. As we know, atoms lose an entire outer shell to become 288, which is argon's electron configuration, D. 15, as the elements in period 3 are considered in order of increasing atomic number, there is a general decrease in. When we take a look at that, period 3 has sodium on one end, and it has chlorine and argon at the other. There's a decrease in, well, remember, as we go this way, we notice a couple of things. You get smaller atoms because you're getting less metallic. And we know that metals are big losers, so as you become less metallic, you become smaller. So there's a decrease in the radius. And we also know that as this happens, you have an increase in both the ionization energy and in the electronegativity. If you forget any of these things, the trend in radius, ionization energy, or electronegativity, if you go to table S, you can simply compare these values and you can reconstruct the trend for yourself. So there is a decrease, as I said, in atomic radius. Mass goes up, electronegativity goes up, ionization energy goes up. Number 16, according to table S, which of the following has the strongest attraction for electrons? Remember, that is defined as electronegativity. So all you have to go and do is go to table S and look up the electronegativities, and you'll find that fluorine has the highest, therefore the strongest attraction for electrons in a bond. Which atom in the ground state requires the least amount of energy to remove its valence electron? Well, that energy is known as ionization energy. I'm going to go back to table S. I'm going to look up their values. There they are. I'm looking for the least amount of energy. The least must be the rubidium with 403. 18, as the elements in group 17 are considered in order of increasing atomic number. That means downward. The reactivity, well, we've been saying right along, fluorine has the highest, iodine has the lowest in the group, so the reactivity decreases. Which of the following group 15 elements has the most metallic properties? Well, guys, keep this in mind that as you go down a group, you always get more and more metallic. So it's really asking which of them is farthest down. Well, it's bismuth. You know that phosphorus and nitrogen are both nonmetals. They're non-metallic. Antimony, Sb, is a metalloid. Bismuth is in the metal area, so that's got to be the most metallic. Many ways to reason it. Number 20, we're not talking about. It's kind of an optional topic. 21, which element is so active chemically that it occurs naturally only in compounds? Well, there are 3 groups that are so reactive that you never find them in free form in nature, only combined. It's groups 1, 2, 17. The question could also have asked, if it were very straightforward, which of the following elements is not, is in either group 1, 2, or 17? Well, K, potassium, is in group 1. 22, explain in terms of electrons why the radius of a potassium atom, which is 281, is larger than the radius of a potassium ion, which is 288. Oh, well, it's simply because of this. I lost a shell. A shell is lost when the ion was formed. Number 23, said in terms of the number of electron shells, why strontium in the ground state is larger than the radius of magnesium. Well, my friends, strontium has a total of 5 shells. Magnesium has a total of 2 shells. 24, state the general trend in first ionization energy down group 2. We'll just go to group 2. As you go down the group and you look up the values, you're going to see a decrease in both ionization energy and electronegativity. 25, explain in terms of configuration, while selenium 2,8,18,6 and sulfur 2,8,6 have similar chemical properties. Well, they have the same number of valence electrons. Number 26, base your answer with this information. Why does cesium have a lower first ionization energy? You simply can say that the cesium has more shells, has more shells than rubidium. 27, write the Lewis dot diagram for the ionic compound MgO. Mg is a metal. The metal ion gets no dots, it gets its charge. Look it up on the periodic table. The non-metal always gets 8 dots, square brackets, and its charge. Write the ground state configuration for the magnesium ion. Well, in this one, magnesium is 2, 8, 2. It loses that 2 and it becomes 2, 8. Oh, John, you can come back. I'm just finishing my thoughts.
Recording the YouTube video?
Oh, short one. Finally, guys, number 29. Stop. Base your answers on this. It's asking which of these has the excited configuration. Well, my friends, if you look at your reference table, this is for calcium. That is the ground state configuration. If I remove that out of that last energy level, I get an ion configuration. That one here, Y, is the excited configuration. Well, that is a review of that exam. Thank you very much. I hope you found that profitable. Let's say bye-bye, guys.
Bye.
Bye.
Bye, future me.